Hello everyone and welcome to 7th grade Math Module 6, Geometry. In this video we're looking at lessons 20 and 22, Real World Area Problems and Area with Circles. Our learning goal is to make sure we can calculate the area of composite figures in real-life contextual situations and decomposition of polygons and circular regions. This will help us to master Standard 7 GB6, solve real-world and mathematical problems involving area, volume, and surface area of 2- and 3-dimensional objects composed of triangles, quadrilaterals, polygons, cubes, and right prisms. In order to solve these problems, we are going to be using our area formulas from our formula sheet. You should refer back to the formulas on this sheet anytime that you are working with a problem where you are solving for area. In order to solve for the area of composite shapes, we are going to need to be able to decompose or break down the shape into its smaller shapes and then refer back to our formula sheet to see what their formulas are. And then we will either combine them if the shapes are combined, or we will take away areas of pieces that are missing. So in this first purple shape, I have here two different shapes, and I can kind of break it apart in my head and see that on top I've got this lovely little semicircle, and then on the bottom I have that nice little four-sided shape where I have one pair of parallel sides and none of the sides are the same measure. That's a shape I always find students getting stuck on. It's a trapezoid. Trapezoids don't just look like your usual little small top, long on the bottom, and then equal slanting slides toward the middle. They can show up as just a rectangle with one slanted side, kind of. So I have a semicircle here and a trapezoid, and I need their formulas from my formula sheet. Well, a trapezoid is actually strangely easy enough. On my formula sheet, it tells me that the area of a trapezoid is 1/2 the sum of its two bases times its height. So all I have to do here is plug in my numbers, and I can solve it. But there's no formula on there for a semicircle, so instead what I have to do is, since a semicircle is half of a circle, I take the formula for a full circle, and then I just find half of it, and then that's my formula for my semicircle. So half of my area of a circle, which is pi times radius squared. So I'll find the area of the semicircle first, just because it's on the left here. So first I look at this and I need to find my radius, but I don't have a radius, so at the bottom of my circle here, I've got this line which is my diameter. It goes through the center of the circle and hits the outside on both sides. It's the longest line I can draw through my circle. And my radius is going to be half of my diameter, so I'm going to have to cut that in half to get a radius of 2. So it's going to be 1/2 times pi times 2 squared. So then to solve this out, 2 squared, 2 times itself, gets me 4. And then if I multiply my regular numbers together first using that commutative property, where I can multiply in different orders, half of 4 is 2. So I could stop here and say my area is 2 pi meters squared, but I know I'm going to have to add this with something else that's not going to be in terms of pi because it's not an area of a circle or a circular piece. So I'm going to estimate using 3.14 for pi to find that this is around 6 and 28 square meters. So that's my semicircle. Next I need to find the area of my trapezoid. So my bases are just going to be my parallel sides here. That's the 4 and the 6. And my height is going to be the perpendicular 90-degree distance between the two. Now in this shape it doesn't have marked whether or not I have 90-degree angles here, but I can let you know based on the context of where this shape came from that that was supposed to be the case. Please don't just assume this. If you have a question in class about a shape, please ask me. If it's on something like the PSSA and you don't see something marked or noted, don't assume. So I put in those numbers there, and then following my order of operations, I take care of my parentheses first. So 6 plus 4 gives me 10 for the sum of my bases, but then I have to do 1/2 times that number times 2. And half and 2, they're just going to cancel out because half of 2 is 1. So in the end, I could find that half of 10 is 5 and then multiply by 2 to get back to 10. Or I could look at that and sort of cut that out in my mind. So the area of my trapezoid is 10 square meters. But the question isn't what was the area of each, it's what's the area of them together, the shape that I make when I put them together. So since these shapes were put together in the shape, I'm going to put them together with addition. And that gets us 16 and 28 square meters. You can pause the video here and try to find the area of the shape below by decomposing it, which I kind of already helped you out with, writing down your formulas, plugging in what you know to your formulas, and then adding if you're combining or subtracting if you're taking apart. So in this shape, we have what looks like a semicircular chunk taken out of what looks like it could have been a square originally. So I'm going to use the area formula of my square in solving this, and that formula we talked about for a semicircle, which is just half, and then the formula of a circle, since a semicircle is half of a circle. I plug in what I know. The side of my square is 6 feet, so I can do 6 squared. You could have also used the area formula for a rectangle, length times width. It still would have gotten you 6 times 6, which is 36 square feet. And then for my semicircle, my radius would again be half of my diameter, but there's no diameter marked here, there's no radius marked here, there's nothing marked at all on this side of the circle. But I know that if this is a square, that these two parallel sides, and I know I kind of drew the one in, would have the same measure. So that distance that I drew in purple would be the same as the 6 feet on the opposite side. So I can use half of that diameter to get me my radius of 3. Sorry, half of 6 is 3. So then, following my order of operations, I have to do the 3 squared first. So 3 times itself is 9. Don't think 3 times 2, think 3 times itself. And then I can find that half of 9 is 4.5. So I could just do 4.5 pi, but again, I'm going to be combining this with something that is not in terms of pi, so I'm going to use 3.14 to estimate. And I end up with 14 and 13 square feet when I use 3.14 for pi. So then for the last piece of this, I had that chunk that was missing from here, and that was the semicircular chunk. So since that was taken away from the square, I'm going to take away the 14 and 13 square feet from the 36 square feet to get that the area of the green shape that's left is 21 and 87 square feet. The last thing we're going to do is we're going to find the areas of parts of circles, and there are 2 ways that we can do this depending on how our circle is drawn and what information we're given about it. So whenever we're doing areas of parts of circles, we always want to start with the area formula for our circle, and then we can multiply it by a fraction or decimal or percent to represent how much of the circle we're looking for. So there's 2 ways for doing this depending on how it's drawn. The first is with sectors, which are just those equal size pizza slice pieces of our circle. They might not be equal size, but in this case they are. And when they are equal size, we can write a fraction to represent how many pieces we're looking for. We just do part over whole. So in this one, we have a total of 8 little pizza slices in our circle here, 8 equal size sectors. And then 3 of them are highlighted, so we've got 3 out of 8 sectors from this circle here. So then we do 3/8 times pi times our radius of 12 feet squared. And then we just follow PEMDAS to solve. 12 squared is 144, and then 144 times 3/8 gets us 54. So our area of the shaded part of the circle is 54 pi square feet. We can just leave it in terms of pi because we weren't asked to do it otherwise, and we're not going to be combining it with anything that isn't in terms of pi. But not all of our circles that we're going to work with are going to be drawn up into nice little pizza pies like this. Some of them, instead of giving us how many pieces total are in the circle, will just give us the piece we're looking for and a number of degrees for the measure of the angle at the corner of that circle made up by the 2 radii sides. So in that case, we can still do the same strategy of doing a fraction times the area of the circle, but in order to do our fraction, we're going to have to take our degrees. And we talked about in our angle lessons about how when we're finding the measurement with angles on a point, that our angles on a point all added up to 360. And that's because when we put them all together, it made a nice circle when it went around. Just like in this picture, we can see there are the 8 angles formed by those 8 sectors meeting there. So we can use the fact that there's 135 degrees in the sector we're looking for, and then divide that by 360, and we have a fraction when we set it up like that, 135 over 360. Then we're going to do the same exact strategies we used to solve with the other one. PEMDAS, order of operations. 12 squared is 144. And then when we do 144 times 135 over 360, we find that we get the same exact answer as when we had 3/8. And the reason for that is because 135 over 360 is equal to 3/8. So again, you're not generally going to have both of these options in a problem. You might have sectors available to you, or you might have angles available to you. Generally not both. So just make sure you know when you see those degrees not to panic, that there are always 360 degrees in the circle, so your number of degrees that you have is your part, and the number of degrees in the circle, 360, is your whole. What does this video make you wonder about solving for the areas about shapes, composite shapes, parts of shapes? Write your questions down so you don't forget them. Then you can try to find answers online or ask a classmate or teacher. Thanks for watching, and when you're trying this on your own, remember, if you learned from your failures, then you succeeded.